All right, so here we want to divide 2x to the fourth plus 6x cubed minus 10x plus 3. And that's the dividend. And we want to divide that by x plus 5. Okay, here we want to use synthetic division. Remember, synthetic division can only be used in specific cases, right? So if the divisor is of the form x minus c, right? So it has to be a linear factor. It has to be x to the first power, okay, and also with no coefficient in front, okay? So as long as the divisor is a linear factor, then we can do this using synthetic division, right? Okay, so in this case, right, what is c going to equal in this example? Right here, c is -5, okay? So remember, why do we divide things together, right? Well, we can divide things together, but the key is if the remainder is 0, right? What can we conclude if the remainder is 0? Right? If the remainder is 0, we can conclude two things, right? We can conclude that c is a 0, right? A 0, we call it a 0, we call it a root or a solution, right? Also, f of c, right? If we evaluate the polynomial, okay, at c, we should get 0. Okay? And actually, it turns out it doesn't matter what the remainder is, right? It doesn't matter what the remainder is. If we evaluate the polynomial at the value of c, right, whatever number we get, that's actually always going to equal the remainder, which is pretty neat. Okay? So let's go ahead and we'll divide this using synthetic division. But first thing also we notice is, look at the dividend, right? We have an x to the fourth term, we have an x cubed term, but wait a minute, there is no x squared term. Okay, that's very important, right? So there is no x squared term, but we got to make sure we account for that in the synthetic division. Okay, so let's just go ahead. We'll write down the value of c, which is -5. Okay, we'll do our half box here, and then we'll write down the coefficients of our polynomial. Okay, so we're starting out with 2x to the fourth, 6x cubed. Notice that there is no x squared term, but we need to write it down, right? It's a 0. Think about it. If we didn't write it down, and we just wrote down the -10 and the 3, right, then there would only be 4 numbers here, which would be the wrong polynomial. So that's why it's very important, right, to keep track if there's any missing terms in the dividend. Right, now in the synthetic division, we always bring down the first number, right? We always bring down the first number, so in this case we get 2. Okay, and now we multiply and add. Okay, so you want to remember that phrase, multiply and add, right? Well, what do we multiply? We multiply 2 times -5, and then we add these together. So 6 plus -10 is -4, and then we just repeat this. Okay, -4 times -5 is +20. We'll add these together. 20 times -5 is -110. Okay, so we'll add these, it's -100, I'm sorry. I was thinking ahead here, right? And then add these together to get -110. What happens when we multiply these together? -110 times -5 is +550. So when we add these together, what do we get? 553. This is the remainder. Okay, so this is the quotient, right? This is the answer. Once we divide these, the answer should be what? 2x cubed minus 4x squared plus 20x minus 110 plus the remainder over the divisor, right? So this is the answer. Okay? But we can, once again, we can notice one more thing here, what the remainder tells us, right? If this was the original polynomial, okay, if this was the original polynomial and I said, hey, evaluate this at f of -5. So I said, okay, plug in the -5 here, plug in -5 here, plug in -5 here, and do all the work. What should the answer be? What do you think we're going to get as the answer? The answer is actually the remainder, right? The answer is going to be 553.